Alright, so today we're going to look at solving for a variable, which is also known as literal equations. When you're solving an equation for a variable, as opposed to just finding x equals a number, what you're doing is rearranging the formula. It's called literal equations because often you're dealing with formulas that literally mean something. So it's going to be really handy in physics. But let's start out with an algebra equation. Let's look at the equation y equals mx plus b. And let's say we wanted to solve this equation for m. We wanted to have m equals. That's our goal. So that means we want to get m all by itself. If you recall, when we solved regular equations, we made a do and undo chart. We can use that same idea to solve this for a variable. So let's go ahead and let's create a do and undo chart. What I want you to do is I want you to look at that equation and think, what is done to m? So if we're looking at it, it looks like the first thing that happens is m gets multiplied by x. So in the do chart, I'm going to write multiplied by x. Then we add b. Then at the end we get y. So we multiplied by x and we added b. So now let's make our undo chart. Undo chart. To undo adding b, we subtract b. To undo multiplying by x, we divide by x. Let's use our undo chart to solve this equation for m. So draw your line through the equal sign, and it looks like minus b. Subtracting b is the first thing you need to do. So now I have b and minus b, which cancel out. I have y minus b. Y and minus b are two different things, so they can't be combined. We have to just keep them as y minus b. On the other side, we have mx still. Alright, now the second step in my undo column is divide by x. So I'm going to divide this side of the equation by x. Now, since we divided by x on this side, we also need to divide by x on the other side. X over x makes 1, so they cancel out. So we're left with m here, and we have y minus b divided by x on the other side. So we just solved our equation for m. If you don't like looking at it like that, you can always flip the two sides. That would be m equals y minus b divided by x. Now, it is a little bit messier than dealing with numbers because more often than not you can't combine like terms. However, like I said, this is going to be something that it will be incredibly useful when you are working with physics equations. So now let's look at a physics equation. We're going to solve this physics equation for m. The equation that we have is F equals ma. That's force equals mass times acceleration. So if we start out again with our do and undo chart, we want to isolate m, so we want to think, what was done to m? It looks like the first thing that was done to m was it got multiplied by a. Now, nothing else was done to m, so that's it. We're ready to do our undo. Undoing multiplying by a would be dividing by a, and that's our only step in our undo column, so that's all we have to do to solve for m. So I'm going to divide this side by a. And since it's an equation, I need to also divide that side by a. A over a is 1, so they cancel out. And what we're left with on that side is m. These can't be combined. You can't simplify f over a right now. So it just has to say f divided by a, or f over a. Now, if you want to, remember, you can always just flip the two sides and say m equals f divided by a. So, mass equals the force divided by the acceleration. Here's that exact same equation, but this time we want to solve it for a. So, that means we need to undo everything that's done to a. If we do our do and undo chart, the first thing that's done to a is it gets multiplied by m. And that is the only thing that gets done to a. So, in our undo chart, we're going to have divide by m. We're going to do our undo chart in that order, which is really only one step, to solve this equation for a. I'm going to draw my line through the equal sign, and I'm going to divide this side by m so I can get a by itself. Since this is an equation, we also need to divide the other side by m. M over m is 1, so they cancel out. You're left with a on this side and f over m on the left-hand side. And again, you can always flip these around and say a equals f divided by m. So in this case, acceleration is the force divided by the mass. So where things get a little bit trickier is when we're dealing with operations other than adding, subtracting, multiplying, and dividing. So in this case, we actually have a squared. This is the equation for the area of a circle. The area of a circle is pi r squared. So what we need to think about is how we're going to get rid of that squared. Now we're going to do this in the same method we did the other ones. We have the do and undo chart. Now let's look at the right-hand side of the equation. We have pi times r squared. So the first thing that happens to r is it gets squared. I'm going to make a little squared in my do chart. The second thing that happens to r is it gets multiplied by pi. So we have our do side undone, finished, and now we can do our undo side. So we need to divide by pi to undo multiplying by pi. Now we have to undo a square. Think about what the opposite of squaring something would be. Be taking the square root. So in our undo column, I'm going to take the square root. This is the order we're going to use to isolate r or to solve for r. So if we follow our undo chart, the first thing we need to do is divide by pi. Pi over pi is 1, so they cancel out. And you're left with r squared on that side. On the left-hand side, we have the area divided by pi. Right now, we don't know the area, so we're just going to leave it as a over pi. Now, the next thing that needs to happen, according to my undo chart, is to take the square root. So I'm going to take the square root. And since this is an equation, I need to do the same thing on both sides, which means I'm going to take the square root of the other side. Well, taking the square root of something undoes the squaring, so all we're left with on the right-hand side is r. And again, since we don't know the area, we're going to leave it as the square root of a over pi. One little thing to note is that normally when you take the square root of something, you need to add a plus or minus. Because think about what negative 3 squared is. Negative 3 squared is also 9, just like 3 squared is 9. But since this is a literal equation, we're probably not going to have a radius that's equal to negative 3, so we can kind of forget about that part. And we can just say that r equals the square root of area over pi. Not saying that you can always forget the plus or minus, but in this case, since our radius is only going to be positive, we can leave it that way. So we have another geometry equation here. This is the perimeter of a rectangle. The perimeter of a rectangle is 2L plus 2W. We want to solve this equation for W. So that means we're going to be focusing on what gets done to W. When we make our do and undo chart, what is over there with the W? What gets done to W first? Well, it looks like the first thing that happens to W is we multiply it by 2. The next thing that happens to that W is we add 2L. Don't worry about the fact that L is getting multiplied by 2. We don't care about it. We only care about W, so we only care about what gets done to W. Now when we create our undo side of the chart, we need to undo adding 2L, so we're going to subtract 2L. Then we need to undo timesing by 2, so we're going to divide by 2. Now we have our order for solving this equation for W. So let's go over to our original equation. Let's draw our line through the equal sign, and let's start following the undo chart. First thing I need to do is undo 2L. So to undo 2L, I'm going to subtract it. 2L minus 2L, well, it's like saying you have 2 of something. You take them away, you don't have any left over. So all that's left on the right-hand side is 2W. Now P minus 2L. You don't know the perimeter, nor do you know L, so we're just going to leave it as P minus 2L for now. Now I'm going to go back to my undo chart. The last thing I need to do is divide by 2. So I'm going to divide that side by 2 to get w alone. But since it's an equation, I need to also divide the other side by 2. So 2 over 2 is 1, and I'm left with w on that side. On the other side, we have perimeter divided by 2, or minus 2l divided by 2. And again, we can flip this around if we want, and we can say w equals p minus 2l over 2. And you can leave your answer like that. You might notice that you can probably simplify this one a little bit more. P divided by 2 can't get simplified, but 2l divided by 2, well, those 2's could cancel out. So another way that you could write this one was w equals p over 2 minus l, because those 2's would cancel. Doesn't matter which way you leave your answer, they're both correct because our goal, remember, was to solve for w. Here we have another physics equation. This is the power equation. It says that power equals work divided by time. This one's kind of unique, and I'm going to show you 2 different ways to solve it. The first way I'm going to show you is thinking about ratios and proportions. I have a ratio, work over time, equals power. But we could make this a proportion by changing power into a fraction. Power would just be power over 1 as a fraction. Now that we have this proportion set up, we can use cross multiplication to solve this. P times T and 1 times W. So P times T is just P times T. 1 times W is just 1W. You don't have to write the 1 there. You can if you want, but it's not necessary because when you divide anything by 1 or multiply anything by 1, it's still itself. So the equation for W, solved for W, is PT, power times time. That was one way to solve this equation. You can solve this equation using the do and undo method as well. We're solving for W, the first thing that gets done to W is it gets divided by T. So if we want to think about what would undo dividing by T, it would be multiplying by T. Now since this is an equation, if I multiply by T on one side, I need to multiply by T on the other side. So T divided by T cancels out to make 1, and we're left with W. T times P is what we have on the other side. Now this is exactly the same as the other answer we got. We have W equals T times P or P times T. It doesn't matter which order you write them in because multiplication can go in either order. So you should always be on the lookout for problems that can be done like a proportion. Cross-multiplying is sometimes quicker and more straightforward when solving for a variable. This is the power equation again, and this is where using proportions is probably a little bit easier than doing a do and undo chart. So that's what I'm going to do. Power equals work divided by time, and since work divided by time is a ratio, I can write the other side as a ratio as well and use cross multiplication. So we're going to do P times T, and we're going to do 1 times W. So we have PT on one side, and we have 1W, or just W, on the other side. And I know this looks like we're, last time we were already done, but in this case, remember, we're solving for T. We want to get T by itself. If we look over here, T isn't by itself yet. It's still got P multiplied by it. So how do you undo multiplying by P? You divide by P. P divided by P is 1, so we can cancel those out, and then we're left with T. On the other side, we have W divided by P. We can't simplify them because we don't know them yet. So we were able to finish our equation this way, saying time equals work divided by power. Everybody should be really familiar with this formula. A squared plus B squared equals C squared. That's the Pythagorean theorem for right triangles. We're going to solve this for B, so that would be if we knew the hypotenuse and we knew one of the legs and we wanted to find the other one. Solving this for B is pretty handy because sometimes these can get messy with all those squares. Because it is kind of messy, I'm going to make sure to do a do and undo chart this time, because there are a lot of variables and we want to make sure we focus on the correct one. In this case, we're solving for b, so we want to start with b. The first thing that gets done to b on that left side of the equation is it gets squared. So that's the first thing in my do column. The next thing that gets done to b is it gets added with this a squared. So we add a squared. Now that's all that happens to b. So we're done. I know that you might want to do some things to the other variables, but it doesn't matter. All that matters is solving for b. So when we look at our undo chart, we are going to undo adding a squared by subtracting a squared. Now we need to undo squaring. Remember what the opposite operation of squaring was? It's the square root. So we're going to follow our undo chart in this direction, up to bottom to top, and we're going to solve this equation for b. So let's start by undoing a squared. Let's subtract a squared. A squared minus a squared is nothing. It's 0. I took it away. So we're left with b squared. On the other side of the equation, c squared minus a squared. Can't combine those because they're not like terms, so it just has to stay c squared minus a squared. Now the next thing I need to do is take the square root. So I'm going to take the square root of both sides. So b squared, square root of that, cancels each other out and you're left with b equals. Now, it's tempting to cancel out more squareds, but you cannot do that because of that minus sign. So we're just going to leave it as the square root of c squared minus a squared. Do you remember that little trick I told you about earlier with square roots? You have to remember to put in that plus or minus. So really, b equals plus or minus the square root of c squared minus a squared. But again, let's think about this. This formula really means we're solving for sides of a triangle. Are you going to have a side of a triangle that's negative? Probably not on this planet, but you never know. So I'm just going to go ahead and write this as b equals the square root of c squared minus a squared. Because for us, on Earth, triangles are not going to have negative sides. Alright, time for another physics equation. This is the physics equation for kinetic energy. Kinetic energy equals 1/2 mass times velocity squared. We're going to solve this one for v, which in this case is velocity. So I'm going to make my do and undo chart. So if we are looking at just v, we're focusing on v, we knew v and put it into this formula, the first thing we would do is square v. So in the do column, I'm going to put a little squared. Then the next thing we do is we multiply it by m. And then we multiply it by 1/2. Multiplying by 1/2 is the same as doing what other operation? Multiplying by 1/2, cutting something in half, is dividing it by 2. So I'm going to write divided by 2 in my do column. Now let's fill out our undo column. The opposite of dividing by 2 is multiplying by 2. The opposite of multiplying by m is dividing by m. And the opposite of squaring, you guys should be good at this now, is doing the square root. So we have 3 things in our undo column. That's okay. If we do them step by step, we should be fine. I'm going to draw my line down the middle, and I'm going to start with that first step, which is multiplying by 2. I'm going to multiply this side of the equation by 2. And since it's an equation, I need to multiply the other side by 2. So now I have 2 times the kinetic energy equals, well, that 1/2 and timesing by 2 cancel each other out, mv squared. So now if we look at our undo chart, the next thing we need to do is divide by m. So dividing both sides by m. M over m is 1, and we have v squared left over on that side. And we have 2ke, kinetic energy, over m left on the left side. Last thing we need to do is square root both sides. So square root, square root. What do I need to remember when I take the square root? Plus or minus. So we have velocity left over equals plus or minus the square root of 2 kinetic energy over m. In this case, again, you can probably ignore the minus and focus on the positive answer. V equals the square root of 2 times kinetic energy over m. You just solve to the sky for V. You may want to come back to this video at some point when you're working on some physics problems and find yourself in need of the equation already rearranged. Alright, last equation we're going to look at, and this is another physics equation. It's a big one, and it has to do with the force of gravitational attraction between two objects. We're going to be solving this one for M2. M2 is in here, and so we want to focus just on M2. I know there's a lot of other variables there, but if we focus on what gets done, and undone, to M2, that's one of the masses, then we should be able to solve this for M2 with no problem. So it looks like M2 is up there, and it gets multiplied by a couple of things first. It gets multiplied by M1, and it gets multiplied by G. The other thing that happens is it gets divided by D squared. Don't worry about the squared in this case because all we need to do is isolate M2. M2 never gets squared. So when we do our undo column, we're going to do opposite operations. We're going to times by D2, divide by G, and divide by M1. That's the order of operations we need to use to get this equation solved for M2. Alright, so let's start out by timesing by D2, or D squared, sorry. Multiply this side by D squared means I need to also multiply the other side by D squared. So, F times D squared equals G times M1 times M2, because the D squareds cancel out. Alright, now if I look at my chart, I can divide by G. Are we dividing by anything else in this case? We're dividing by M1. Why don't we do that at the same time? So, G over G is 1, and M1 over M1 is 1. All we're left with on that side is M2. On the other side, we don't know any of those variables, so they have to stay letters. F D squared over G M1. And we're done. We've solved our equation for M2. If you want to see it in the other direction, you can just flip the two sides. M2 equals F D squared over G M1. This is another one of those equations that you'll want to keep handy because in physics class, this is a messy equation, and when you already have it solved for a variable, it sometimes makes things a little bit easier. So this is solving literal equations, solving for a variable. You use the same principles that you do when you're solving for x equals a number. Using a do and undo chart is a very handy way to make these go a little bit easier.